Hello. Okay, so today we're going to be learning about what is a titration and how do you do one. But before we get into this, we need to consider a PPE, which is some sort of lab coat. I'm wearing an apron right now, gloves in case you get liquid on your hands, and your glasses or goggles so that you don't get irritation since these chemicals can both be corrosive. Okay, so to start off, titrations are done to quantitatively find the concentration of an unknown solution, which is known as an analyte, and by adding a volume of a chemical of unknown concentration. That would be your titrant. In this case, this is an acid-base titration. So our base is going to be NaOH, and our analyte or acid is going to be HCl, which is going to be combined in our conical flask with indicator phenolphthalein. Alright, so using a pipette, we're going to add our base into the burette, and as we turn on this little stopcock, it's going to drip a little bit of base into our conical flask that contains our acid. And we're going to be doing this little by little, swirling every now and then after we add our few drops, because we don't want to go overboard. We want to stop when our solution turns completely pink for about 10 seconds. And this will mean that we have reached our end point or our equivalence point, which is where the neutralization reaction between the acid and the base has come to an end. So the acid and base are equal. So once this happens, we're going to want to find out the change that there was in volume in our burette. So to do this, we're going to need to look at the meniscus. So that's at eye level, as you can see here in the little diagram. And we're going to measure that change. And before we go on to the math, I want you to notice that we have 0.2 mole, a molarity of 0.2 of NaOH, and we have 30 milliliters of HCl. And here we have our balanced equation. So they're both 1-to-1 ratio. Okay? And some tips to do when you're reading your meniscus, you can put a blank piece of paper behind it to better read, and also place a blank sheet of paper or a white surface under your flask so that you can better see the color change. And you're going to want to rinse your burette only with base to keep it accurate and precise with concentration. And you're going to want to rinse your flask with water. Water won't impact your reaction. And it actually reduces the residue that's left on the flask as well. And let's go on to the math. Alrighty, now on to the math. So, as we already did, we measured the change in volume of the titrant to reach the end point, which was signaled by the indicator when our solution turned pink. In this case, let's say it's 30.2 milliliters. Second of all, we're going to find the moles of base that were used to neutralize the acid. So we know that we had 0.2, a molarity of 0.2 for concentration of base, and that our volume for base was 30.2 milliliters, but in order to work with this formula to find our moles, we're going to need to convert that to liters. So that's going to be 0.0302 liters. So by using this formula, we're going to plug in our numbers, so molarity over our liters of base, and we're going to solve for x. And that's going to give us 0.00604 moles of NaOH. Okay, so next what do? Next, we look at the ratio. So we see that this is a 1:1 ratio, and that helps us. So this means that if we have a mole of 0.00604 of NaOH, we're also going to have 0.00604 moles of HCl. So now we need to find the concentration of HCl. So now we put the moles of HCl over our volume of HCl. And if you remember, it was 30 milliliters, and 30 milliliters is equal to 0.0300 liters. So if we do the math, calculate this, we are going to get 0.201 molarity of HCl. But there is another way to do this that might be a little bit more simple, but you can only use it mostly when you have a 1:1 ratio. It makes your life easier. So let's see. Our V1, we're going to do M1V1 equals M2V2. So we don't know our M1, so this would be our concentration of HCl, but we do know the volume, and we can keep it in milliliters. So we put 30 milliliters on this side equals 0.2 M, that we had a base, times 30.2 milliliters of base. So we multiply these two, divide by 30, and our M1 is going to equal 0.201 concentration of HCl. Okay, so sometimes in titrations, mostly every time, you need to do various trials because a lot of errors can occur with titrations, and this will help you to get more accurate and precise results. So let's say that we did 3 trials. To find the average molarity, we're going to add our 3 molarities that we found, and we're going to divide it by 3 because there were 3 measurements. And our averages is going to be 0.205. Okay, and let's say that you want to find the percent error. Okay, so now you're going to take the standard number of a molarity of HCl. Let's say that's 0.200. So you're going to do actual minus predicted divided by actual, but it's going to be absolute value on the numerator always, and then you're going to multiply it by 100. Okay, so this is going to give us 0.2 minus 0.205 over 0.2, and we have a percent error of 25. So that's what you need to know about titrations.